And now for the legal stuff. All right, so here we go. We got Mike Marshall at the controls here. Got the machine all set up. We got the program set up. And I'm gonna walk around here to the side. All right, Mike, go for it. There we go. So now, we come around here, take a look at our component. And we are drilling 2.5 inches into the part. Nice surface finish. We get some really nice chips right there. And we put a witness mark on our component right there so we can see whether or not we were getting any twist, and that part is absolutely not moving. So we're going to cut a few more here, but I'm thinking this is a really successful test. Okay, so did a little bit of experimentation after the jaws had gotten wet, after the paper had gotten wet, and you know, now we kind of got ahead of ourselves, and we didn't do this after we ran our initial part. So what we found after we ran several test pieces, everything had got wet, paper got wet. I reset back up on our test rig right here, and here's our 30 millimeter impact socket that's got an OD of about 1.7 inches. And we got some 220 grit sandpaper in there, wrapping the jaws to give it a little bit of extra bite, because this is slick and the jaws are obviously very hard and have a bit of lubricity to them as well. So right now I've got 110 foot-pounds of torque set up on my torque wrench right here, and I have applied 60 foot-pounds of input torque to my vise. And right now, I mean, that's 110 foot-pounds, and that's not turning, okay? That's with dry paper. What we found out after the fact, which really scared me, was that a lot of the gripping power goes away once the paper gets wet. So we lost quite a bit of gripping power. This particular drill and everything, it takes about 50 foot-pounds of torque for the spindle to push that drill through the part. Okay, that's a drill with a 25 millimeter insert, roughly a 1-inch insert. So we already had a big safety factor there to begin with, and I don't really know how much that we lost. All I know is I set my torque wrench back up at 100 foot-pounds, and it just pulled right around, and that scared me because I thought that maybe something had gone wrong with the jaws. They had deformed or had broken down in some way. So took everything back apart and set back up with dry paper, and that's all it was. The paper was just dry, or excuse me, had gotten wet, and that added lubricity caused us to lose a lot of our gripping power. But with dry paper, even though these jaws are now soaked with coolant, we got plenty of gripping force again. So that's something very important if you're going to be doing an application like this, something to keep in mind. So I just wanted to share that.